In this video, we're going to take a look at the profit maximizing price and quantity for a monopoly. We'll also take a look at profits that are earned, and we'll take a look at a natural monopoly as well. So I've got a lot of information on this slide. Let's start at the beginning. We'll start with a monopolist that has a demand curve P is equal to 200 minus 0.05 Q. And if we take a look at revenue, the revenue function is price times quantity. So we take that price function, which is demand, 200 minus 0.05 Q, and multiply it by Q. And we get a function for revenue that is 200 Q minus 0.05 Q squared. The derivative of revenue with respect to quantity is marginal revenue. And so that's just 200 minus 0.10. And so we call this the twice as steep rule. Let's compare demand to marginal revenue. The only difference there is that we have a slope in marginal revenue that is twice the slope of demand. Same intercept, twice the slope. So you can remember that. That'll be the same as we work through any problem relating to demand in monopoly. The cost function for the firm is C is 100,000 plus 20Q plus 0.0125 Q squared. And then from that, we get the marginal cost by taking the derivative of cost with respect to Q, which is 20 plus 0.025 Q. And so now we have marginal cost and marginal revenue, right? And so we can set those equal. If you move to the right of where we derived marginal cost, you'll see MR equals MC. That's the profit maximizing rule. So MR is 200 minus 0.1 Q. We set that equal to 20 plus 0.025 Q, and then we solve and we get a quantity of 1440. Up on the graph, MR and MC intersect at 1440, at a quantity of 1440. And now we choose the highest price for which 1440 will be purchased. And that's found by plugging Q of 1440 back into demand. So see that long connection there between quantity on the bottom right and then back up to demand on the upper left. And we do that and we get a price of 128, okay? And that's on the bottom left of your screen. And it's also in the graph. So the monopoly price is 128, and then what is profit? In the far upper right-hand side of the slide, you'll see that we have to calculate average cost. So we take the average cost formula, which we didn't derive, but you can derive it, and we plug in a quantity of 1440, and we get an average cost of 107.4. So profit is 128 minus 107.4 times 1440, and that's 29,600. And then I've got that in green, shaded in green. You can see that on the slide there. That height of the green box is the P minus AC, and then the width is the quantity of 1440. If this were a perfectly competitive industry, maybe this is a drug for which the patent has run out, we can find the perfectly competitive price by simply going to the bottom left of the slide. In perfect competition, the intersection of demand and marginal cost dictates the price and quantity, because the marginal cost serves as the supply curve. So if we have generic competition, we should see the price moving down to $80. You can see that on the far left side of the graph. So all I've done there on the bottom left is I've set price, which is demand, equal to marginal cost for the overall market. Okay, and I'm assuming here the marginal cost for the overall market is the same as the individual monopoly marginal cost that we had earlier. And so we get a price of 80 and we get a quantity of 2,400. And we put that in the graph there in maroon. So you can see where monopoly and perfect competition differ. They differ in that monopoly sets a higher price and restricts the quantity produced. Also, we have a deadweight loss area, don't we? Okay, so the deadweight loss area I will put in orange. So the monopolist, by restricting quantity and raising the price, creates a deadweight loss equal to the area in orange. And we could calculate that because we know, for instance, what the marginal cost is of the last unit, we could plug 1440 into the marginal cost function, solve for that quantity, and that would give us the height of that deadweight loss triangle. Then the base is the 2400 minus 1440. Then you have half times height times base. There is a relationship here between elasticity and marginal revenue. And we can look at this formula here. We can derive marginal revenue as a function of elasticity. So marginal revenue is equal to the price times 1 plus 1 over the elasticity of demand. So let's put in the elasticity of -1. Remember, that's at the midpoint, right? So at the midpoint, 1 plus 1 over -1 is 1 minus 1 in parentheses. So 1 minus 1 is 0, and the marginal revenue is 0, where we have unit elasticity. If the elasticity is greater than 1 in absolute value, meaning it's maybe like -1.5, or let's say -2, then marginal revenue is going to be positive. Let's say it's -2. Then in the parentheses, we have 1 plus -1/2, or 1 minus 1/2. So marginal revenue would be 1/2 times P, right? So at that particular quantity where we had that elasticity, we would find that marginal revenue is half the price there. And if it's less than 1, we find that it is negative, right? So let's suppose elasticity is less than 1 in absolute value, meaning, say, -0.5. 1 over -0.5 is -2, so we have 1 minus 2 in parentheses. So MR is P times -1. All right, so this gives us kind of that nice link between elasticity and revenue that we were talking about earlier. So marginal revenue is closer to price as demand becomes more elastic. Okay, as demand becomes more elastic, E becomes more negative, and that last term in the parentheses becomes very small, and then you have marginal revenue becoming closer to price. Okay, so profit maximizing output. Because a linear demand curve is more elastic at smaller quantities, monopoly profit is maximized in the elastic portion of demand. So we just mentioned earlier that we wouldn't want to be in the inelastic portion of demand unless we want to sacrifice short-run profits for some long. Let's think about a particular kind of monopoly, which is called a natural monopoly. A natural monopoly is a situation in which one firm can produce the total output of a market at lower cost than several firms. Okay. Governments frequently grant monopoly rights to public utilities, like your local electricity provider. These public utilities essentially give the utility the right to be a monopoly, but in return, they must be regulated in the price that they can set. In other words, they can't exercise their monopoly power. Let's take a look at a natural monopoly. Now, this is a situation where the upfront costs of infrastructure are really big. So think of an electric utility. They have to build a very expensive power plant. They have to put lines out, electrical lines out to everybody's homes and businesses. So this involves a huge upfront cost. The cost of the electricity itself, of making an extra unit of electricity, is low compared to those upfront infrastructure costs. So that means average cost is falling over the entire range of possible output of electricity, because the major factor there is the average fixed cost portion of that average cost, which is going down as you make more units of electricity. All right, so here we have a natural monopoly with a constant marginal cost of 10 and then a declining average cost. And notice that 60 divided by Q is the average fixed cost portion of average cost. There are two options here that we could exercise in regulating this monopoly, right? So one option would be that if we see demand in maroon, we could say, all right, utility, you have to charge a price equal to the marginal cost of producing an extra unit of electricity. That would be $10 here. The problem with a price of 10 is that if we follow that 10 over to the demand curve, we have 10 units demanded. So people will buy 10 units of electricity. And then we follow that up to the average total cost curve, that 10 units of quantity. Draw a line over to the left, and we see that it costs $16 per unit to provide these units. Well, if the price is 10 and the average cost is 16, that's a loss of $6 per unit. Right? So the overall profit is negative 6 times 10, negative $60. And you can see that in green. So typically that's not what happens, even though that would be efficient because we would have no deadweight loss. Price and marginal cost of the last unit would be equal. So that gives us efficiency. The second best option is to put price at average cost. Okay, now this is going to sacrifice some deadweight loss, but it will allow the firm to earn zero, not negative, economic profit. So normal profit. So we look at the intersection of demand and average cost, and we can see that is at $18. Okay, so $18 is the price that we would force them to charge, and then that would produce a profit of 0, because at 8 units purchased, the price 18 is equal to the average cost of 18. Okay, just ignore that. I think that was from the previous. Okay, so let's take a look at price regulation. So let's start with demand. P is 100 minus 0.02 Q. And we have a cost function here. C is 2000 plus 10Q plus 0.04 Q squared. From that, we can derive average cost, 2000 divided by Q plus 10 plus 0.04 Q. Okay. And if we're regulating this firm, we want to set price equal to average cost. So demand, 100 minus 0.02 Q. Set that equal to average cost, 2000 divided by Q plus 10 plus 0.04 Q. Now, how do we do this? Because we're going to have a term here, Q, if we rearrange and simplify. We'll have an equation if we put everything on the right-hand side that involves 0.06 Q. So we have Q here as a variable, and then Q 1 over Q times 2000 as another variable. So it's not easy to solve for Q in this case. But if you go back up to the upper right, we can use the quadratic formula for this. What we want is we want that equation to be of the form A times Q squared plus B times Q plus C equals 0. Now we don't quite have that form in the lower left. So A and B and C are just numbers, just constants. But we can multiply both sides of the bottom left equation by Q. And if we do that, we get 0.06 Q squared minus 90Q plus 2000. Now it's in the form where we can use the quadratic formula. All right, so A, the constant A is 0.06, B is 90, and C, negative 90, sorry, and C is 2000. So the quadratic formula is shown, and you can use an online calculator as well that can easily calculate it. And we get a quantity of 1477, and we get a price of $70.45. So this would be the price and quantity that we would choose for this natural monopoly. There's a trade-off. If the regulated price is not optimal, in other words, if it's not P equal MC, there's a deadweight loss. But if the price is set below average cost, well, the firm is going to shut down. So usually the second best option, right, in terms of efficiency, is the option chosen, and that's average cost pricing.